Dear students, in this module, we're going to talk about the structure determination towards calculating the energy of a protein. You know that the greater the interaction between the amino acid atoms within a bigger protein, the more stable that protein is. Now, if we want to look at the stability of the protein, we need to go back and see how many interactions and of which type are there within the protein. And then we can simply calculate the energy of a folded protein based on the number and types of these atomic interactions. In order for you to estimate the type of interaction between atoms, you need to look at the distance between them. So depending on the distance between atoms, you can guess the type of interaction that is taking place, and therefore you can assign an energy value that may have been given out when that interaction happened. So based on the specific atomic distances, we can guess the type of interaction. As I mentioned to you, you can look at the energy table and the bond length table that I will just show you again, and then you can sum up all the values in the table, multiply them by the number of atom pairs that are having that specific interaction, and you can have an overall estimation of the protein energy. In this table, you can see there are 4 types of interactions, that is the van der Waals forces, the hydrogen bonds, the ionic interactions, the hydrophobic interactions, and of course, once you know all of them, and the energy given out as a result of the interaction, you also know the length of the bond between the atoms. Then you can calculate the total energy by using this simple formula. So how do you then determine the position of these atoms? Because you want to know the position of these atoms in order to determine which interaction is taking place between them. There are 2 techniques that are typically employed these days. So first one is the X-ray crystallography, and the second one is the NMR, or nuclear magnetic resonance spectroscopy. You can use NMR or X-ray, and you can look at the position of each atom within the protein. You can look at the distance between these atoms. You can assign which interaction may be taking place, and therefore you can sum the entire energy content of the protein. The X-ray and the NMR, as will be discussed in detail later, give you an opportunity to look at these interactions stochastically. So we can only estimate what is the interaction, and there is no empirical or definite statement about the interaction.